Chemistry of a Golf Ball by Greta Koss. The first known golf ball was the wooden ball. It was first made in the 16th century. They were made out of beech wood and were very smooth. Since they were smoothed and contained no dimples, they did not fly very far. The next golf ball was called the feathery. This was made of goose feathers and had a leather outer cover. They were extremely expensive and unreliable. Due to the materials, they broke apart easily, and if they got wet, they would break apart. Worst of all, they were uneven, which impacted the way they would fly, as well as the distance. The gutta percha was the next golf ball. These were the first golf balls intentionally made with divots and dimples. These balls were made from dried rubber like sap of a tree from Malaysia. This sap was heated, cooled, and then shaped multiple times to form into the perfect sphere. The Haskell ball was a ball created in 1901. This ball had dimple-like marks. This ball consisted liquid-filled or solid rubber core and had an outer layer made of sap. So why are the dimples so important? As the ball travels, it pushes the air out of the way, leaving a region of reduced air pressure behind the ball, known as the turbulent wake. Because the wake is essentially a region where air has been pushed away, there is a partial vacuum behind the ball. Air will rush in to fill this partial vacuum. As a result of the air rushing in to fill this partial vacuum behind the ball, drag increases on the ball and the ball slows down. However, with the dimpled ball, the tiny dimples on the surface of the ball create turbulence in the boundary layer, the thin layer of air surrounding the ball. This turbulence is in the form of little edgy currents along the dimpled surface of the ball. Air becomes trapped along the surface of the ball, causing air to flow further down around the ball before it separates to form the wake. Because less air is displaced, more air can flow directly around the ball, decreasing air resistance. The size of the wake behind the ball is greatly decreased. With a smaller wake, there is less drag and the ball travels faster. The modern golf ball is made up of 300 to 500 dimples. It is a structure made up of several layers which surround a core or a one-piece construction. The modern golf ball can be made up of many different types of materials which can be used for different types of play. So now let's look at the golf ball's main chemicals, compounds, and components. Polybutadiene composes the main core of the golf ball. It is a polymer made, a monomer that contains two carbon-carbon double bonds. Ionomer, a cover typically used to cover the golf ball, is a thermoplastic resin. Urethane elastomer is another type of cover used. Has elastic properties associated with rubber. So what is chemistry's role? These ingredients that fulfill a golf ball are traced back to basic elements. The process of making the polybutadiene core is formed by compression molding of chemical reactions. Ionomers are created by melting process, which is a mixture of injections, molding, and compression moldings. The golf ball's hard outside layers are also made up of resins which harden through ionic cross-linkings between negatively charged acid groups and positively charged metal salts, such as zinc and sodium salts. My peer-reviewed article was Modern Sport and Chemistry, What a Golf Fanatic Should Know by Scott E. Kay, Timothy Robbins, and Renee Cole. This is an academic journal. This article references many of the things talked about so far. Some ideas referenced in this piece are layers of a golf ball, materials used in a golf ball, and the future of golf balls. Learning about the chemistry of a golf ball is not only important to me, but also to the community. Golf is a sport and activity that many people enjoy. It's a sport that people of all age ranges and people across the globe play. Learning more about the chemistry can help players at all different levels and make people want to join.